Today we are here to talk to you about the motor project. But before we can talk to you about the motor project and how we built it, we first are going to talk about some history about the motor. It's all started around the 1740s when two men with the name Andrew Gordon and Benjamin Franklin who started to experiment with electrical static motor. It is a type of motor that is based on attraction and repulsive of electrical charge. A couple years later, in 1820, Hans Tristan, a physicist and chemist, noticed that when an electrical current is presented, the needle of a compass deflects from the magnetic north. This confirmed a direct relationship between magnetism and electricity. In the following years, Michael Faraday, a British scientist, demonstrated a continuous rotation using electrical magnetic fields and suspended magnetic wire. Later, in 1824, a man by the name of Franco, a French physicist, showed a rotating copper disc produce rotation in a magnetic needle suspended above it. In 1828, Anois, a Hungarian physicist, invented the first computed rotary electromechanical machine with electric magnets. In 1830, Giovanni, an Austrian mechanic, built an electrical motor using the plans of another Austrian physicist, Andrews. Later, a man named Joseph Henry created a mechanical rocker. In 1833, William built the first computed rotating electric machine that was demonstrated in London. Hilpotai, a French instrument maker, put the first AC generating appetite out of rotation. Later built an oscillating DC generator. In 1837, Thomas, an American blacksmith, attained the first American electric motor patent. Later, Solomon built a 12-pipe electric motor with segmented commutator. In the year 1834, a man named Marzar Valjakob, a Russian engineer and a physicist, built a 15-watt motor and submitted it to the Academy of Science in Paris in 1835. Later, in 1840, Truman Cook, an inventor, built an electrical motor with a PM armature. In 1856, Warren invented a generator with a double T armature and slotted wingings. Later, in 1871, Zarbo developed a anchor ring motor which solves the double armature pulsing DC problem. In 1879, Walter developed the first primitive connectorless induct motor. Later, in 1888, a man by the name Nikola Tesla described a three-patent two-phase four-star motor types, which are listed on screen. A year later, a man by the name Frank Julian developed a new consistent speed DC motor which allowed Spigot Company to issue the world's first important industrial electric motor. In the year 1935, Kepler built a working linear induct motor. Later, in 1945, Liquid made the first full-size working model of the linear induct motor. Here is the cost of each material we used to build this motor. The total was around $50. Here is the material and what they look like. Step 1. First, we cut down everything to size, starting with the shelf. Then was a wooden dowel to 6.5 inches, 4 of the PVC molding to 4 inches. Cut the PVC pipe to 4.5 inches, then cut it into 2 pieces. Cut the 2 pieces of wood to size of 3.25 by 1.25 inches, and at the center of the 2 pieces of wood, cut a circular hole to the size of the bearings. Step 2. Paint. Next, we painted the PVC pipe, the cable conduit, and the wooden box with a gray glossy color. Step 3. Now we get the 4 PVC molding and a wooden dowel to make a plus sign in the middle of the dowel and glue it with hot glue. After it is dry, we add a popsicle stick in between each of the PVC molding. Step 4. After waiting for everything to dry, we started to wrap the magnetic wire in between the plush-shaped dowel. When you're wrapping the wire, you need to make sure that the cable are parallel and straight. When adding the conduit at the end of each of the magnetic wire, you need to remove the coating of wire. We removed the coating of wire by sanding it down until the bare cable was exposed. Step 5. After wrapping the magnetic wire, it's time to work on where the magnet is going to go. First, get one of the PVC half pipe and find the center. Once you find the center of the pipe, glue the magnet onto it. From there, glue 2 magnets up and down until you have a total of 5 magnets on the PVC pipe glued. Make sure all the magnets are pointing in the same direction. Step 6. After the PVC conduit dries, take off the cap of the front and measure where the switches and female adapter will be placed. The female adapter is centered 1 inch from the left side of the cap. The switch is centered 2.75 inches from the left side of the cap. Step 7. Get the conduit casing and glue it onto the shelf. The center casing is 2.5 inches away from the bottom left side of the shelf. Now get the cover and put the switch and the female adapter. Step 8. Now wire the switch and the female adapter. From the female adapter, we got the positive cable and took it to the switch. Then we got the positive cable and came out. Later, we will use both cable as brushes. We tested the switch to see if everything was wired correctly, which it did. Step 9. Now we put the L-shaped bracket that holds the PVC pipe with the magnets. The rightmost L-shaped bracket is 2 inches from the right side and 2.5 inches from the bottom. There is spacing of 2 inches between the L-shaped brackets. Step 10. We glue the PVC pipe with the magnets to the L-shaped bracket. We use zip tie to separate them to hold them in place while we glue them down. Step 11. Now we screw in the 2 blocks of wood. The blocks is centered in the shelf. 2 pieces of wood are 8.25 inches apart. We have to put the shaft with the magnetic wire now so it fit perfect. After everything is in place, we screw it in. Step 12. Now we added the brushes. The cable from the conduit box from earlier are our brushes. We use the zip ties to hold the brushes to the conduit. We messed around with the brushes until we got it where we want it. Then we taped it down. Step 13. We are done. We are just about ready to start testing it. I am gonna play a clip of our motor in action right about now. Welcome back to our station. Well, we would do different. We would improve on the brushes and condiment. The condiment causes too much friction, which in turn slowed it down and reduced the RPM, the speed of the motor. We would have soldered the magnetic wire to a copper condiment. Also, we would have improved the brushes on how they connect to the condiment. Recommended for next year, we recommend you don't leave it till last minute. Also, we recommend you learn how a motor actually works and not just copy from a video. The end.